in this section, we're going to be learning about triangles that are not right triangles. In fact, in the next couple sections. And so what we need to refresh on is what an SSA triangle is and what an ASA triangle is. So in this particular section, we're just going to be focusing on the law of sines. So if I look at a triangle and draw a little picture, look, it's a triangle. Okay, an SSA triangle simply means as you rotate around, you'll know a side. So there's side 1, and you'll know another side, and then you'll know an angle. So I don't know this included angle. But what you do notice is I look at side 1 and this angle is I know a completed ratio. So what we were talking about in the last section is finishing out triangles. So you'll notice that an angle and the side opposite that angle will make a completed ratio with the law of sines. So I can find the other side and I can find the other two angles. What you need to also keep in mind is that you cannot use Pythagorean theorem unless you've verified that it is a right triangle. So we're not dealing with right triangles in this. Another type of triangle that we're going to deal with is angle side angle. So again, as I rotate around, I will know an angle. I'll know the side next to it, and then I'll know the next angle. Okay? So if you know two angles of a triangle, that means that you'll know the third angle because you'll subtract from 180, which means, again, I'll have a completed ratio. So I'll know the angle as well as the side across from it. So I'm looking specifically in this section at using the law of sines on SSA and ASA triangles. And the law of sines says this. I've got the sine of A over little a equals the sine of B over little b, which equals the sine of C over little c. So as we covered in the last section, we're going to label our angle measures as capital letters, and then we're going to label the sides across from them as lowercase letters. So this is A, B, and C. So I can know any part as long as I've got a completed ratio. Okay, so I'm looking for completed ratio. So if I've got a sine A over A and I know little c, well then I can ignore the B parts and figure out what the sine of C is. So what we're going to focus on, again, is going to be SSA and ASA triangles. And then there's going to be a time where we're going to have an ambiguous case. Okay? So if we have an ambiguous case, we are going, it may mean that there's multiple triangles. It may mean that there's no triangle. It may mean that there are one triangle, or it could be a right triangle. So there's all these issues. So what we're going to do is, I'm not going to get to it yet, but again, the first side of this handout, we're going to look at, can there be triangles or no triangles, two triangles, no triangle, what's going on? Okay, and that's going to be the case if I have a side-side angle. So diving in, we're just going to practice a little bit first. So I have a triangle here. And this triangle is a 95 and is a 60 and is A. And then I have little a, little b, and a 6. So I know simply from what I learned 5 seconds ago that if this is little b, then across from it is big B. And if this must be C. Okay, so, and I don't know what big A is or what little a is. So the first thing you need to recognize, now I'm all for shortcuts. How do I know if I've got an ambiguous case or not? Your question is, do you have all three angles? If you've got all three angles, you're not going to have an ambiguous case. So, and that's right off the bat, because I can create angles or find angles as I go. But right off the bat, I've got 1, 2, I can find that angle simply by subtracting from 180. So all of my angles are accounted for. This is not an ambiguous case. So the first thing that we're going to do is find that missing angle. So I've got 180 minus 95 minus 60, and that's going to give me 25 degrees. So I know that A is 25 degrees. Now, the way I'm going to organize this throughout these couple sections is I'm going to have big A and little a. I'm going to have big B and little b. And I'm going to have big C and little c. So having all three angles and all three sides means that my triangle is complete. So what do I know so far? I know I've got big C at 95 degrees. And I've got little c at a measure of 6 units. I know I've got big B at 60 degrees. And I don't know little b. And I just found big A. I just found out that big A is 25 degrees. Okay, so again, how do I know if it's not ambiguous? I got all three angles. I am good to go. This is not an ambiguous case. So do I have a completed ratio? Yes, I do. I've got the sine of 95 degrees over 6. So I have the sine of 95 degrees over 6 is going to be, and then I want to find one of the other sides. So as a matter of practice, what I usually go for is the smaller side or the smaller angle. Well, I'm looking for sides, so I need to look at angles. So I'm going to use 25. Okay, and you'll find out that that's going to help in the long run. So I'm going to use the sine of 25 over little a. So I'm using the sine of big A over A is going to equal the sine of big C over C, and I don't care about B yet. Okay, so I'm just setting this ratio up, and now that I've got a ratio, I can cross multiply. So I have A times the sine of 95 equals 6 times the sine of 25. And now I can solve for A. So I'm going to divide both sides by the sine of 95. Sine of 95. So any number divided by itself is 1. So little a is going to be 6 times the sine of 25 over the sine of 95. Okay, so using your calculator, for the love, make sure you're in degrees and not radians. You have 6 times the sine of 25 divided by the sine of 95. So when I complete that, I find out that that side is 2.55. So little a is 2.55. So 2.55. Now, do not be tempted to go in and use Pythagorean theorem at this point because it's not a right triangle. So I just need to find little b. Now, another thing that you want to do is always go back to your original ratio because it's not rounded. You won't have rounding error here. Whereas if I use this to find this, I've rounded this. So this won't be as exact as it could be. Okay, so I'm going to use, and I'm going to learn to write closer to the left margin. I've got the sine of 95 over 6 is going to equal the sine of 60 over little b. Okay, so cross multiply. I've got b times the sine of 95 equals 6 times the sine of 60. You cannot see. And then I'm going to divide both sides by the sine of 95. Divide by the sine of 95. So I end up with b equals 6 times the sine of 60 over the sine of 95. So putting that in my calculator, 6 times the sine of 60 divided by the sine of 95 is going to give you 5.22. So I have now found all three angle measures and all three side lengths. So my triangle is now complete. So let's practice again. We have, and again, I'm going to learn how to write closer to the left side. All right, so I'm going to draw my triangle. And what I have is this shape, which is a triangle. That's 130. This is 30. And I've got little b and big B. I've got little a and big A. So this must be little or big C and little c. So I'm going to start off by saying I've got big A, big B and little b, big C and little c. And fill in what you know first. So I know that big A is 130. I do not know what little a is. I do also know that this is 5, sorry. That would be important. Okay, so that's 5. And then I've got B. Well, I don't know what B is until I realize I've got 2 angles. If you've got all 3 angles, you do not have an ambiguous case. So this is going to add up to 160, which means this must be 20. I got 3 angles. It's not ambiguous. You're like, what does ambiguous mean? I will tell you in a moment. And then across from that, I don't know what that is. And then big C is 30, and little c is given as 5. So I have a completed ratio. I got 3 angles. This is not ambiguous. And I can use the law of sines. So the law of sines says, take your completed ratio, so the sine of the angle over its corresponding side, equals, and then I just naturally drift towards the smaller representation, whether it's a smaller angle or whether it's a smaller side. So I'll have the sine of 20 over little b. And now I can cross multiply. So b times the sine of 30 equals 5 times the sine of 20. Divide both sides by sine 30. So I find out that b is, and I have 5, what do I have? 5 times the sine of 20 divided by the sine of 30 gives me 3.42. So that is 3.42. So little b is 3.42. Do not use Pythagorean theorem. This is not a right triangle. And now I can use my initial ratio, because this one is rounded, use my initial ratio and I can find little a. So that gives me the sine of 30 over 5 will equal the sine of 130 over little a. So I'm going to cross multiply. I've got a times the sine of 30 is 5 times the sine of 130. Divide both sides by the sine of 30. So any number divided by itself is 1. And then I've got 5 times the sine of 130 divided by the sine of 30 gives me 7.66. So I know that little a is 7.66. I've got 3 angles and 3 side lengths, so my triangle is complete. So let's do another one. And then actually let's try and squeeze 2 more in rapidly. And then we'll look at some ambiguous cases. So we have the following triangle. I've got A is 40, B is 20. So A is 40 degrees, B is 20 degrees, and little a is 3. Okay, so I already know I don't have to draw the triangle, but out of habit, I always do. Okay, so there's my triangle. I know that this is 40. I know that this is 20. And I know that little a is 3. So again, out of habit, unless I'm told otherwise, I always make this A, B, and C, which makes this little a, little b, and little c. So I do not know little b, and I do not know big C or little c. But wait, I do know big C, because I know that 3 angles add up to 180. So 180 minus 60 will give you 120. And so I have all 3 angles. This is not an ambiguous case. And so I use my initial completed ratio with unrounded values. So the sine of 40 over 3, and I'm going to drift to this one because he's smaller. So it gives me the sine of 20 over little b. So cross multiply, b times the sine of 40 is 3 times the sine of 20. Sorry, I forgot to silence my phone. All right, so we're going to divide both sides by sine 40, which gives me 3 times the sine of 20 divided by the sine of 40. And I end up with 1.596, which is going to be 1.60. So I know that little b is 1.60. That's the rounded value. So I'm going to go back to my initial ratio. So the sine of 40 degrees over 3 will be the same as the sine of 120 degrees over little c. and cross multiply. So C times the sine of 40 is 3 times the sine of 120. Divide both sides by 40, or sorry, by the sine of 40. So 3 times the sine of 40, times the sine of 120, divided by the sine of 40, gives me 4.04. So I have 3 angle measures, and I have 3 side lengths. So let's do one more, just for practice, and then we'll start looking at some ambiguous cases. So I've got big B is 30 degrees. I've got big C is 40 degrees. I've got little c is unknown, little b is 4, and theoretically I know nothing about A. But I know I can find it. So 180 minus 70 is going to be 110. So I got 3 angles. This is not ambiguous. Okay, I can find these side lengths. So use your completed ratio. So the sine of 30 over 4 will needs to be the same as I drift towards the smaller one. So the sine of 40 over little c. Cross multiply. So c times the sine of 30 equals 4 times the sine of 40. And then divide both sides by the sine of 30. So 4 sine 40 divided by sine 30 is going to give me 5.14. So little c is 5.14. And use your initial ratio. So I have the sine of 30 over 4 will equal the sine of 110 over little a. And cross multiply, so a times the sine of 30 is 4 times the sine of 110. And divide both sides by the sine of 30. So 4 times the sine of 110 divided by the sine of 30 gives me 7.52. 7.52. So 3 angles and 3 side lengths means I have a completed triangle. So we will pick this up in a second video.